NVIDIA just dropped something that can literally change how fast AI models generate text. And honestly, when I first read about it, I was shocked. They are calling it TiDAR. And listen carefully. This thing can make LLMs generate text almost 4 to 6 times faster, without losing the quality we get from normal AI models. And in this video, I'm going to break down TiDAR in a way no one else will. Alright, before we actually understand what TiDAR does, let's first talk about why NVIDIA even needed to create something like this. And trust me, once you understand the problem, TiDAR automatically starts making sense. So the thing is, every big AI model you use today, whether it's ChatGPT, Claude, Gemini, Llama, anything, they all use something called autoregressive generation. Autoregressive basically means the model creates text one token at a time. Simple, it reads what it has generated so far, then generates the next token, then reads again, then the next. And this keeps going. And this method gives us very high quality text, no doubt about that. But because the model has to wait for each token before generating the next one, the whole process becomes painfully slowly, especially when you are trying to generate a long paragraph. And the funny part is, while all this happening, your GPU is literally just sitting there waiting. Imagine you have a super fast engine, but you are forced to drive at 10 km per hour because the road is narrow. That's exactly what's happening inside AI inference. The hardware is ready for full speed, but the autoregressive generation forces it to slow down and generate one tiny token at a time. Now, some people might ask, why don't we use diffusion models? They generate everything in parallel, right? Yes, diffusion models are insanely fast and super parallel, but the problem is they are not good with text. Their token predictions get messy, unstable, or grammatically weird. So even though diffusion is fast, the quality just isn't usable for normal language generation. That's why you don't see diffusion ChatGPT or diffusion Gemini. Companies cannot sacrifice quality for speed. And this is where the real question appears. Can we get speed of diffusion and the quality of auto-regression together? Because if that happens, AI becomes faster, cheaper, more practical. And trust me, companies care about this a lot. Every extra second an AI model takes to generate output cost money. When billions of requests are made every day, a small speed increase becomes millions of dollars saved. Token generation speed is directly equal to the cost of running AI. Faster model is equal to cheaper to run is equal to better apps, smoother user experience, and more scalable AI products. This is exactly why NVIDIA stepped in. They looked at the industry problem and said, okay, AI models are too slow, GPUs are underutilized, AI quality is great, but generation is bottlenecked. Diffusion is fast, but quality is bad. So what if I combine them perfectly? And that's the birth of TiDAR, to solve a very real, very expensive, very annoying problem that every AI company faces today. Alright, so now that we understand the problem, let's talk about what TiDAR actually is. And trust me, once you understand this part, everything else in the video is going to make complete sense. So TiDAR stands for Think in Diffusion, Talk in Autoregression. And I love this name because it literally tells you the whole idea. The model thinks using diffusion, which is super fast and parallel, and then it talks using autoregression, which gives you the high quality text we all expect from modern LLMs. So you get the speed and the quality together without compromising either one. Now here is the part most people misunderstand. So let's clear that right now. TiDAR is not two models stitched together. You don't have one model doing the drafting and another model verifying. Everything happens inside a single model, in a single forward pass. So there is no second helper model, no extra memory load, no extra latency. This is a huge deal because it keeps things lightweight and actually practical for real world use. And the coolest part, TiDAR reuses the KV cache. This is extremely important because KV cache is the memory of previous tokens. Most speculative decoding techniques break or waste the cache, but TiDAR fully reuses it. That means it behaves exactly like a normal LLM when it comes to quality. But internally, it's generating way more tokens in parallel before finalizing them. So yes, it thinks like diffusion, but it still speaks like a proper AI model. So here is what happens behind the scenes. First, the model reads your prompt or question. just like any normal LLM. Nothing crazy yet. But instead of immediately generating the next token one by one, like traditional models, TiDAR does something smarter. It actually creates a small block of empty spaces. Think of them like a blank boxes the model wants to fill. This is the draft area where the magic starts happening. Inside these blank slots, TiDAR uses a diffusion style thinking process. Now remember, diffusion is super parallel and super fast. So instead of filling one box at a time, TiDAR fills many boxes at once. These are not final answers, these are the model's best guesses. It's draft tokens. And because it fills multiple slots together, it saves a huge amount of time. It's literally thinking ahead, multiple steps in one shot. But the important part is, and this is where auto-regression comes back in, once those drafted tokens are ready, TiDAR doesn't just throw them at you, it immediately switches into auto-regressive mode and checks each of those drafted tokens one by one. It verifies them, corrects them, and ensures they make sense in context. So you still get the same high-quality, accurate output that AI models are known for, but at the speed of parallel drafting. And once the final tokens are approved, the model outputs them. Then it repeats the whole cycle again. Draft fast, refine carefully, output cleanly. That's why TiDAR gives you speed without sacrificing clarity or accuracy. The easiest way to understand this is with a simple analogy. Imagine you are writing a paragraph. Instead of writing one perfect sentence at a time, you quickly jot down the whole paragraph in rough form. Then instantly you read it again, fix the mistakes, polish the sentences, and then show it to the world. That's exactly what TiDAR does. Alright, now let's talk numbers. Because at the end of the day, hype is one thing, but performance is what actually matters. And honestly, the results NVIDIA showed for TiDAR are seriously impressive. When I first saw these numbers, I had to double check because they look almost unreal for a single model approach. So here's the big one. TiDAR boosts throughput by around 4.7 into 5.9. And that's not on tiny toy models. They tested this on real practical sizes like 1.5 billion models and even 8 billion models. These are the sizes used in actual apps, actual chatbots, actual production systems. And TiDAR just sits there casually giving nearly 5 to 6x faster decoding without asking for a second model, without special hardware, without complicated pipelines. Now the best part is, speed didn't destroy quality. This is where most inference tricks fail. But with TiDAR, the output quality is almost the same as normal ear decoding. Accuracy? Same. Coherence? Same. Reasoning? Same. If you showed two outputs side by side, 99% of the people wouldn't even know which one came from TiDAR. And for anyone wondering, is it worse than standard HR in complex reasoning? The answer is no. In fact, because the autoregressive verifier that corrects the draft, you maintain exact quality levels. Now, before we get carried away, let's slow down for a moment and talk about the limitations. No technology is perfect on day one, and TiDAR is no exception. It's important to understand where things stand right now so you don't walk away with unrealistic expectations. The first thing you need to know is that TiDAR is still very new. Everything we're discussing comes from early research tests. Yes, the results look amazing, but they have only been tested on the 1.5 billion and 8 billion scale models. We still don't know how TiDAR will behave on huge 70 billion or 400 billion scale models, the kind that companies actually deploy for serious workloads. Big models sometimes behave very differently, so until those tests happen, we can't assume the same 5x speed boost everywhere. Also, not every workload will get the same improvement. If your model isn't generating long sequences, or if your application is extremely latency sensitive for the first token, you may not see dramatic changes. Drafting blocks help a lot with throughput, but the speed up depends on how many tokens you are generating at once. Short queries may not benefit as much as long responses. Another thing to keep in mind is that NVIDIA hasn't released official code yet. So if you're wondering, can I implement this in my model today? The honest answer is not right now. Until the code or official libraries come out, developers will have to wait, and you know how these things go. Sometimes the research paper arrives way before practical tools do. There is also a technical challenge here called mask scheduling. This structured attention mask that makes TiDAR possible. It's powerful, but it's not trivial to implement. You have to decide which positions draft in parallel, which stay casual, how often you refresh them. It's a careful balancing act. If you get the scheduling wrong, you either lose speed or lose quality. So early implementations may require a lot of fine-tuning. And yes, drafting multiple tokens at once might increase VRAM usage slightly because the model needs temporary space to hold those draft positions. It's not a huge downside, but for people running models on limited GPUs, it's something to be aware of. Alright guys, so that was TiDAR, and tell me in the comments which AI topics should I break down next, whether it's a new model, a new architecture, or a new breakthrough. I want to explain it in a way that actually makes sense to real people, without hype, without confusion. And of course, if you want to keep learning AI with clarity, then make sure you subscribe. Trust me, this is just the beginning.